So now we've put together quite a few powerful building blocks towards being an effective data scientist. I want to take a moment to just describe your objective as a data scientist in your organization. So really the primary role of a data scientist is to become a translator. What do I mean by that? Your first job, even when you're starting, is to take a business concept and translate it into machine learning. What do I mean by that? Is if your boss comes to you and asks, hey, will this item sell out? Right? You have to take it and translate it into the machine learning definition that we described earlier, right? I want to minimize loss over a set of functions subject to regularization, right? Can I translate the business objective into a machine learning objective? You see, many people work extremely hard on the wrong problem because a lot of times there is no machine learning formulation for the problem at hand. Let me give you an example. If you worked at, say, a drug company or at a health system, right? And we ask the question, which one is better? Should we give this patient drug A or drug B? Which one would be better for them? And we have data. This is not a machine learning problem. We cannot translate it into the definition that we learned earlier. Why is that? Is because here we have what we call a counterfactual, a what if scenario, right? We're saying, would you get better if you take drug A or if you take drug B? And that is outside the scope of machine learning. It is, you could frame it as a machine learning algorithm potentially, right? But it is not the forte. It is going to end. The danger of machine learning algorithms is that they always give you an answer. It is your job as a human to say, I do not know. The algorithm is never humble enough to say, I don't know. And it is your job as a data scientist to maintain that humility. So step number one is to translate the business requirements into a machine learning definition that we mentioned earlier. You'll build your model using best practices, making sure that your data is clean, making sure that your data are representative of your process, making sure that you're splitting your data properly, all these things that we discussed earlier. You get your results, you analyze your test data set with cautious optimism, right? That this is an offline exercise and maybe when data comes in live, things might not look the same. But here's the key now. Now it's time to present results to your stakeholder. And I have seen this countless times. If you just avoid this mistake, you are going to be ahead of other data scientists in the organization and around the world. You'll have a data scientist come into the room, especially if their results are exciting, and they're meeting with business stakeholders. And you know what they start doing? They start saying false positive rates, ROC curve, AUC, area under the ROC curve is also called AUC, AUC. And they'll give these numbers. And you know what happens? They lose their audience. They lose their audience. All that hard work went down the drain because we were unwilling to let go of the technical jargon. AUC means nothing to somebody. Classification error means nothing to somebody. Misclassification rate means nothing to somebody. What you have to do here as a data scientist is to take the statistical insight and translate it back into business language. You see, so basically you are a translation box. You took the business, you translated it into machine learning, you did some machine learning work, you did your due diligence, you take the output of that, and you translate it back into the language of your stakeholder, which is business. So for example, remember when I mentioned the false positive rate of a test being 40%, right? So that's something that you can explain. So you did all your due diligence, you did the accuracy, you did the confusion matrix, you computed F1, you did the AUC curve, you did everything, and you looked at all the different ways that you could slice and dice the data, and what remained salient to you was, for example, the false positive rate, right? So now, even though you did a lot of work, maybe this took days or weeks to perform, you have to be humble enough to let it go. Let it go. right? And all I'm gonna have in my slide is just the false discovery rate, the false positive rate, right? In which case you go back to your CEO, you say, madam, you know, this test is great, but it has a false discovery rate of 40%. And that is, and you tell them, and then you just let them see, is that tolerable? Is that acceptable for our members, right? And this is a real world example. Who had this problem from the mainstream media? You probably know about them, right? Theranos. If you remember the startup Theranos, who claimed that they can do all sorts of tests with a single drop of blood, right? A needle prickle, right? And it became this huge scandal that they couldn't. I am certain that a data scientist went and told their CEO, right? Or whoever it was, that look, it can't be done. Look at these results. Look at the false positive rates, right? Look at the false negative rates. Look at these different things. So these are simple and straightforward concepts. We could explain to them very quickly, right? But they're very powerful if you use them at the right time and at the right place. So now what you want to do is to be able to let go of the technicalities, because you have to make a choice in your career now. Do you just want to be a deeply technical person, or do you want to be a highly influential person in your organization? And I'll give you a real example of this. I was working with this young student when I was a professor, and he built a model that predicted hurricanes, right? I was working in global climate change, and he put together this model that took very interesting data sets and did very interesting things. And as you probably know, predicting hurricanes is extremely difficult. When a hurricane is going to occur, where it's going to occur, is it going to make landfall? Those are critical questions for our survival, but we know very little about them. And the student kept showing me results, and they were always 99% accuracy. Every year they're able to predict with 99% accuracy how many hurricanes are going to happen in the Atlantic, right? How many are going to make landfall? And I kept asking him, but 99% is so high. Right now, even if we did 80%, if we did 75%, we'll be much better than anything else out there. What is causing this 99%? How are we getting to 99%? And he will just not let go. He will just kept driving that accuracy. He would not let go. And guess what? That work never went anywhere. Climate scientists wouldn't believe him. Computer scientists wouldn't believe him. Why? Because he would not let go of all the deep technical work that he did. Yes, it was hard work, but what you want to have is influence. And that work has never been published. I've never seen it, unfortunately. Maybe it was good work if we just let go of a little bit of the complexities in the model that made it artificially high in terms of performance, but then we will have gained traction in our stakeholders. In our case, it was scientists. In your case, it might be a business stakeholder. So I hope this is helpful guidance for how to increase your influence while deepening your technical expertise within your organization.